All right. January, I did a presentation on old computers. 40-year-old computer that I had that talking about digital stuff. I talked a little bit at the beginning about the analog world, better, and the advancement of things. I held this thing up. Of course, we have the lights out. We can't see this, but there we go. I didn't really talk at all about what it was. It's a slide rule. And this was the pocket computer of the day. So I thought a little more in depth on what these things are, how they work, and what the deal is. Growing up, slide rule was magic. Slide rule was high technology. Slide rule was rocket science. There's nothing that, I mean, this thing embodies all of what high technology was about. And come to find out that, no, actually, it's not rocket science. It's not easier than that. It's actually, the technology behind a slide rule is a simple equation. Log A plus log B equals log A times B. Right? Easy. Any questions? What's a log? Okay, what's a log? Yeah, well, okay, so logs are good. And properly configured, you can actually compute with them. Now, this may not be quite as automated as people want, you know, but you can compute with logs. Okay, log is a logarithm. What's a logarithm? Well, you look up on Wikipedia, and it has a nice concise definition. The logarithm of a number is the exponent by which other fixed what? Okay, ignore all that. The deal is a log has this funny curve that goes in this shape, and you've got a linear scale here, and then you've got this weird thing on the side that kind of maps linear to this compressed thing. Maybe you've seen graph paper with funny stuff on it, or other ways with this weird scale, and that has some magic properties. This is magic. This is wonderful stuff because you can compute with it. Okay, so how do you do arithmetic with logs? Well, it's easy. So if you have, bear with me, if you have a 2-foot log stacked with a 3-foot log, you end up with a 5-foot log. You just did math. You did addition. Now, bear in mind, this is with real logs. If you go with the fake logs, like the carpenters use, when they think that a 2x4 is actually 1 3/4 by whatever it is, that doesn't count. This is the real stuff here. Okay, so we just added with logs, right? So with this, you can build your own slide rule. You can take a ruler, linear scale, helps us made out of wood, and you put another ruler next to it. Now, if I look at 3 plus 6, I get 9. I get 9, right? I just added with 2 scales. I can do math. Now, you can also learn in reverse, right? You can say 9 minus 6 is 3. And if last night during the net I had one of these sets of things, I could have figured out what UTC was for local time. But I didn't do that. Okay. Now, if you have these funny scales, you can do multiplication. And here's where the magic comes in. That formula, log A plus log B, well, here's log of 2 plus the log of 3. I get the log of 2 times 3, or the log of 6. I just did multiplication. And you can do it as fractions also, upside down. Let's see, right here. 3 over 6, right, is 1/2 or 0.5. I can do division. So with 2 simple scales, sliding back and forth, I can do math. Okay, that's neat stuff. This has been around for a while. Logs were first, not invented, you don't invent physics. They were discovered back in 1614. John Napier figured out what a logarithm was. They weren't actually written down as a scale until about 1620. 12 years later, someone actually put 2 scales together to do some math. 220 years. Lieutenant in the French Army created what is the configuration that we now know as a slide rule. So, 1850, so we got, another couple hundred years here till the modern day. There's been a lot of stuff that's happened since then. Things where more scales are added. You've got log, square, tangent, all these fancy things. Adds more to the rocket science aspect of slide rules. You've got, yes?
I heard that Al Gore invented physics.
Al Gore, no.
Just the internet.
He just invented the internet. So his slide rules powered the internet. You see. With these scales, you can do funny things. So you got the D scale and the A scale. The A scale is the D scale twice. When you multiply something by itself, you're squaring it, right? So you can take 3 and look up here, you get 9. 3 squared is 9. Ooh. There's also a K scale that's got 3 of them next to each other. Well, what's 3? It's cubes, right? So I can take 2 cubed is 8. You move the cursor thing back and forth. So they've got different scales, things you can do differently with sines, cosines, all this stuff, all kinds of mathematical functions. And some interesting configurations. The round slide rule is interesting. It's nice and small. A 3-inch slide rule has a 9-inch circumference. The longer the slide rule, the more accurate it is. And so you can get a lot in a little place. They have funny scales on them. Who's got the other slide? Yeah, the other slide. Anyway, some in the back there. Yes, Bob has other function slide rules. You can take a look at them during the break. But aeronautical ones that do all kinds of transforms, so you know if you can run out of gas before you land or not. I guess you land when you run out of gas. I really want this watch. Normal watch, but around the outside is one of those funny scales, so you can sit there doing math on your watch. Advantages. What's the big deal about slide rules? Well, they never read batteries. You can run them in this shade in the sunlight. My cell phone does not work in the sunlight. Underwater, stir your coffee with them. They're wonderful things. I swear, I did see somebody at Berkeley when I was there with one hanging fashionably from his belt. If you can imagine this, it was not me. It was not me.
Sheldon Cooper.
Could have been Sheldon. Yeah, no, it's a freshman, I think. Walk in front of Wheeler Hall. Anyway, okay. Other advantages. Slide rules force you to think about the problem you're solving. Calculators are wonderfully good ways of coming to the wrong answer with absolute precision and certainty and confidence, right? You know you got the right answer even though it's upside down. Real world precision. How many people have bought a bag of almonds? Pound of almonds, right? It says 1 pound, 343.6 grams. 0.6 grams. Yeah. Oops, too much. Shave off a little bit of the last one, put it back in, right? Real world is not out to 4 places, guys. And slide rules are perfectly adapted for that. Ratios, for converting things or taking, like I was an engineer at HP, right? I'm doing performance measurements. This is 30 years ago. Performance measurement is stuff over time. And I'm doing ratios, and I'm sitting there banging numbers into it, and it's just too much work. Pulled out the slide rule, set it up, better, worse, I can see instantly what's going on. And those custom scales, they got apps. Okay, challenges. Where's the decimal point? Remember that thing with the fraction? 4/8 is 0.5. Was it 5? It's 0.5. It's a decimal point. You got to know what you're doing. It's really, you got back to understanding the problem. The precision is related to the size. Circular is better because of the multiplying by pi and the size. There were in high school or junior high, they had these demonstrator things on like chalkboard-sized slide rules hanging down. They were fantastically accurate. Also, the skill of the user. You can't do addition. It is possible. I've done it. Not easy, but you have to use other identities to figure that out. And of course, as the eyes get older, they get harder to read. So what's it do with hand radio? Well, think about the timeline on calculators and the timeline of the equipment, especially the boat anchors that we have. Most of the stuff was either figured out by hand, by experiment, or by slide rules. That's all there was to compute, really, that and the abacus. And if you want some skill training, try to figure that one out sometime. But until the mid-70s, and the slide lieutenant I have up here, I got in college because that was kind of the transition, and I was cheap that year and got a slide rule. Make sure I had a calculator. But I decided to challenge myself, and I took the advanced test using my slide rule. I passed. So it can work. Anyway, any questions?
I got a comment.
Hang on a second. Question first?
I got a comment.
Okay.
So he can go first because he was the first comment.
I was just going to say, I was a lot faster with the slide rule all the way through college than with the calculator. I was always the first one dropping the test, and everybody else was giving me the evil eye. But it's so much faster.
Slide rules can be very fast.
Yeah,
If you,
I just
yeah.
They're there, tick 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 tick, punch punch. Scowl at it and do it again.
Yeah, the clear key in between about every third yeah.
Right, where I work out, my orders of magnitude, and then I zip, and I'm done.
Yeah, yeah. They can be a lot faster. Same with my ratios in performance measurement. Yes?
The comment number 2 is that they're actually increasing in value as time progresses.
Increasing in value.
Yeah.
I haven't actually looked for one.
You should look one up because they got zeros after their value.
Whoa! That's good to know.
Yeah, so hang on.
Yeah, the 10-inch one I got in college, I forget what I paid for it. It was like $30 or $40 or something like that. And the little one was my dad's. I don't know what he paid for it, but he designed airplanes. One of the scales is not printed exactly right. It's like off by like just a hair.
Yeah, 2 zeros.
And but I'm wondering how many airplanes he designed with that slider.
Because they're still flying.
Yeah, the T-scale on the backside is not perfectly done. Any other questions? Okay, thank you very much.